All right, ministry exam questions of chapter 1, section 1. The first title is rotational quantity. So we are going to answer these questions. The first question is every 2 pi radian is equal to how many degrees? So this is very simple. So one revolution or one rotation is equal to 2 pi radian. So 2 pi radian, and we know that every one revolution or one rotation is equal to 360 degrees. And next one, every 1 radian is equal to how many degrees? This is definition of the radian, remember. So 1 radian is equal to 57.3. If you remember, it is defined like this. So on a circle, if an angle is equal to 1 radian, so let's say that this angle is equal to 1 radian, so it was equal to 57.3. So the angle whose arc length, which is delta s or s, is equal to its radius. So if this r and s were equal, so then we said that it is 1 radian, and this 1 radian is equal to 57.3. Which of the following angles is equal to 2 pi radian? So these questions, third one and the first one, are the same. So 2 pi radian is equal to 360 degrees. And next one is for 270 degrees is equal to how many revolutions? So we are going to use the revolution degree equivalence. One revolution is equal to how many degree? Because degree is given here. Here is the revolution is asked. I have to write the relation between revolution and degree first. We know that 1 revolution is equal to or corresponds to an angle which is equal to 360. Remember, 1 revolution means, so the object will start from here and then complete the turn and come to the same point again. It's called 1 revolution, so it is 360 degrees. And then, what is the question? Calculate. So 270 degrees is equal to how many revolutions? So x. Simple cross product we are going to use here to get the result. So cross product means you are going to multiply x by 360. X multiplied by 360 degrees is equal to 1 multiplied by 270. So I'm not going to write 1 because if you multiply a number by 1, so the result doesn't change. And then, because all the answers are given here, the rational number, don't use the calculator here. So to get the x, we should simplify 360 by dividing both sides. 360, however, so you shouldn't use calculator. If you use the calculator, you will get a not rational number. That's why you should go simplification. So go first, cancel these, simplify these zeros, which is 27 over 36. After that, find the simplified is by the same number. For example, if you divide 27 by 9, yes, you can divide it. 36 divided by 9, yes. So 27 divided by 9 is 3. So divide by 9, 27.9 is 3. 27 divided by 9 is 3. Divide by 9, 36 divided by 9 is 4. So answer is 3 over 4 revolutions. And 1 degrees is equal to how many radians? Sometimes students can get confused these definitions. For example, here is 1 radian is equal to how many degrees asked, but here is 1 degree is equal to how many radian is asked. Better to check the answers. Answers are given in terms of pi over 180. But for this, when I see something about better to use the equation for converting degree to radian, like this. Theta in degree, theta in radian. Remember, we are going to convert degree to radian. That's why we should use that equation. How we convert it? So theta in radian is equal to pi divided by 180 multiplied by theta in degree. This was the equation for converting. To remember this equation is not so hard. Look at here. This is pi. Pi half circle. This is 180. 180 half circle. You divide half circle to half circle. So you see that they are equivalent to each other in fact. But not same unit. This is in radian. This numerator in radian. Denominator is in degree. So that's why pi divided by 180. This ratio corresponds to normally they are equal, it's 1. However, expressed in different units. You are going to convert degree to radian, so these degrees must cancel. So that's why 180 must be here, because sometimes students can get 180 here or there. So it must be here because degree and degree must cancel. That's why one of them is in numerator, the other one must be in denominator. They must cancel. So then you will get the result as radian because pi is in radian. Anyway, so this is the equation. So after that, you are going to insert it here 1 instead of theta in degree. Just write 1 here. So theta in radian is equal to pi is 3.14 radian divided by 180 degrees multiplied by 1 degree. So then answer is going to be, degrees and degrees will cancel, 3.14 divided by 180 radian, which is the choice C is the answer. And next question, which is for 6.1. 45 degrees is equal to how many revolutions? Again, it's very similar to that one. We are going to use degree revolution equivalent. We know that 1 revolution is equal to 360 or corresponds to 360 degrees. So then 45 degrees is equal to how many revolutions? So just cross product again. Cross product. So x multiplied by 360 degrees is equal to 1 multiplied by 45 degrees. So then to get the x, just simplify by 360 divide by 360. So then it will simplify. There is no rational number. That's why we can use calculator here. So I'm just simply divide 45 degrees. 45 divided by 360 and get the answer 0.125 revolutions. So choice is B. And 1/10 revolution is equal to how many degrees? Again, revolution degree conversion. We know that 1 revolution is equal to or equivalent to 360. And then 1/10 is asked. So then which means divide both sides by 10. Divide by 10 to get 1/10 revolutions. Simplify zeros. It's 36 degrees. So answer is C. And 314 divided by 180 radian is equal to how many degrees? It's asking to you. This is converting from radian to degree. So I'm going to use equation, which is 1 radian. 1 degree, we will convert radian to degree. So degree, theta in degree is equal to. So then 180 divided by pi or pi over 180. Of course, 180 divided by, because 180 is in degree, pi is in radian. So that's why, so then theta in radian, I'm going to write here, this radian and that radian will simplify. So you will get the result as degree. That's why not pi over 180, 180 divided by pi. And let's insert this into the angle in radian. Angle in degree is equal to 180 divided by pi is 3.14 radian multiplied by so 3.14 divided by 180. So then they will simplify each other. So answer is 1 degree. So it is D for this question. And I will solve now the mystery exam questions of second title, which was the angular displacement and angular speed. The first question, 2014 mystery exam question, Angular displacement delta theta is given, arc length delta s is given. Calculate r. We will use definition of angular displacement. However, to use that, we should convert first this 135 degree to radian, because in calculation we never use degree in calculation in this equation. Which equation? Let's write it. Delta theta is equal to delta s over r. When we divide this length by that, we got an answer radian. That's why this angle must be converted to radian. Let's convert it. There are multiple methods for converting, but I'm going to just use the method in the book, which is there was an equation. Theta in radian is equal to pi divided by 180 multiplied by angle in degree. This was the equation in the book. And then let's write pi is 3.14 divided by 180 multiplied by 135. So let's use the calculator. 3.14 multiplied by 135 divided by 180 is the answer. 2.36 radian. Now we can use this equation. However, r is asked, so that's why you should write this equation in terms of r. Just r and delta theta exchange their positions. So then in the equation, r is equal to delta s over delta theta. Delta s is given in, it's suitable. It's the SI unit meter, 2.6 divided by angle in radian, 2.36. So let's divide them. 2.6 divided by 2.36, which is equal to 1.1. 1.1 meters is the correct answer, which is A. And next one is Abedel sits at the top of a bicycle wheel, assuming that the wheel turns clockwise. Remember, clockwise rotation is negative. It represents the negative. So what is the Abedel's angular displacement, which corresponds to an arc length of 1.2 meters, and the wheel reduces 40 centimeters. So delta s, which is arc length, is delta s, but it is negative because clockwise rotation, we will write it negative 1.2 meters, but r is as no direction, so r is also always positive. It's given in centimeter, so 40 centimeters, so it must be converted to meter by dividing 100. You should divide 40 centimeters by 100 to get the meter. 0.4 meters is the radius, and now we can use a definition of angular displacement. Delta theta was equal to delta s over r. Delta s is negative 1.2 divided by reduces 0.4. Now let's divide it. 1.2 divided by 0.4, which is equal to 3, but negative. Don't forget negative 3. Radian is the answer. Choice is B. Choice B. And how long does it take to rotate the second hand of a clock by 30 degrees? Second hand of clock, we know that one rotation of the second hand is one rotation takes how many seconds? Second hand, 60 seconds, of course. And we know that one rotation corresponds to 360 degrees. One rotation, one revolution, all the air corresponds to 360 degrees. So then we can say that 360 degrees takes 60 seconds. But how many degrees? 30 degrees takes how many seconds? It's asking 30 degrees takes how many seconds? Cross product again. So then x multiplied by 360 degrees is equal to 30 multiplied by 60. 30 multiplied by 60. So to get x divided by 360, divide by 360. Simplify them. So at x is going to be, let's do it now, 30 multiplied by 60 divided by 360, which is 5. It takes 5 seconds. It takes 5 seconds. Answer is B. And fourth question is the rate at which a body rotates about an axis. When it says, remember, divided by something, some quantity will be divided by time. Rate means this. At which a body rotates upon an axis, usually expressed radian per second. Here is unit is given. Rate of rotation is called also, which means angular displacement delta theta divided by delta t, which is on average angular speed. Or just look at the unit. Radian per second is the unit of average angular speed, which is choice B. And again, rate the time rate of change of angular displacement. Yeah, which means you are going to divide change in angular displacement by time, and delta angular displacement divided by time, which is equal to omega. Again, angular speed, omega average, delta theta over delta t, which is the angular speed. And question number 6. How long does it take for the second hand of a clock to move through 4 radian? This time, this question and that question are similar, but one of them is according to angle asked. This one is asked according to radian. So we know that, again, one rotation of second hand takes how many seconds? 60 seconds, of course. Second hand, 60 second one rotation takes. One rotation, how much angle, how much radian, which is, of course, we know that it is 2 pi radian, 6.28 radian. 6.28 radian of rotation takes 60 seconds for second hand. So 4 radian takes how many seconds? Cross product again. So x multiplied by 6.28 is equal to 4 multiplied by 60. Simplify by 6.28. Simplify by 6.28. So let's use the calculator and then find the answer. 4 multiplied by 60 divided by 6.28, which is equal to 38.2. 38.2 seconds. X is 38.2 seconds, which is choice A. A bicycle rider moving in a circular track, if he cuts a quarter, which is 1/4 of the path in 10 seconds, what is average angular speed of the bicycle? Here is, he cuts 1/4 of the path, means circular path, of course, 1/4 of circular path. This is defining revolution, 1/4, full revolution, half revolution, or quarter revolution. So the angular displacement in revolution is given 1/4. 1/4 means 1/4 revolutions. A delta t, this is time for this. Delta t is given, which is 10 seconds. This takes 10 seconds. But in calculation, we don't use revolution. We should convert revolution to radian. How? We will multiply by 6.28, of course. Every revolution, every angular displacement revolution must be multiplied by 2 pi radian, which is 6.28 radian. So you convert it to radian. So which means 1/4 multiplied by 6.28. You are going to get angular displacement in radian. So that multiplying 6.28 by 1.4 means dividing by 4. So 1/4 means divided by 4, which is equal to 1.57. 1.57 radian. Now we can calculate the average angular speed, delta theta in radian, divided by delta t, which means 1.57 divided by But delta t, which is equal to 10, so it becomes 0.157 radian per second. So average angular speed is 0.157 radian per second, which is B. And it's a very similar question, 8.1. Here, a bicycle rider rides along a circular track. Yes. If the bicycle travels around exactly 3/4, which is 3/4 of the track in 10 seconds, only change is here. You are going to write 3/4. So all time is the same. You are going to multiply this answer by 3 to get that one, but I am going to show again first. Angular displacement in radian must be calculated, which is 3/4 revolution multiplied by 6.28. So 6.28. So let me show the calculation to you. Yeah, 6.28 multiplied by 3 divided by 4. You will get answer by this way, which is equal to 4.71 radian. And then we will get average angular speed, which is equal to delta theta over delta t. Delta theta 4.71 radian, delta t in 10 seconds. So 0.471 radian per second, which is equal to A. And the next one is find the average angular speed of Earth about the Sun in radians per second. Hint, Earth orbits the Sun once every 365.25. Once. One revolution. So angular displacement is going to be 1 revolution. And 1 revolution is equal to 6.28 radian. And what is this 365.25 days? It's time for 1 revolution. Delta t. Delta t is 365.25 days, but we don't use days. Answer must be given in meter radian per second. Second, we should convert days to second, but I will convert it just in the equation. Omega average is equal to delta theta over delta t. Just insert it here. Then omega average is equal to delta theta 6.28 divided by delta t, so which is 365.25 days. Days will be converted to hour because every day is 24 hours multiplied by 24. Every hour is 60 minutes multiplied by 60 minutes. Every minute is 60 seconds multiplied by 60. But don't forget to put bracket in the denominator, otherwise your calculator will incorrectly find the answer. So let's do it. 6.28 divided by, yes, put a located in a bracket. Without bracket, you cannot get the correct answer. 365.25 multiplied by 24 multiplied by 60 multiplied by 60, but close the bracket, which is 1.99. 1.99 times 10 to the power of negative 7 radian per second, which is choice B. The correct answer. And a cyclist rides along a circular track. It's the question 7, 8, and 10. Similar questions. A cyclist rides along a circular. If the cyclist travels around exactly half the track, half means half of the track, 1/2 revolutions. So of course, 1/2 revolution must be converted to radian. And this is angular displacement in 3 pi seconds. Here is delta t is given in pi, which means sometimes they are doing these things. They don't give directly the 3 seconds or 5 seconds to make you easily calculate the result. Without using calculator, you can calculate this. So first thing you should do is to get angular displacement in radian. So 1/2 revolution. We know that every revolution is 6.28, but this time use pi, okay? because here is pi is given in the delta t, just write here 2 pi. So 2 and 2 will simplify. Answer is pi radian. So delta theta in radian is equal to pi radian. Now get the average angular speed by equation delta theta divided by delta t. Delta theta is pi radian. Delta t is given 3 pi seconds. Pi and pi simplify 1 over 3. So in here, please do not use, as I said, pi 3.14 because rational number is asked. If you use calculator here, you will get 1 over 3, which is equal to 1 over 3 is equal to 0.33. And when you look at the choice, you will see that there is no 0.3. You can get panic. So then in here, when you see a rational number in the choices, better not to use calculator. Just go with simplifying, okay? So 1 over 3 radian per second, which is choice D is the correct answer. And I will continue with the questions. There are a few questions about angular acceleration and kinematic equations of the ministry exam question. The first one is a drill start from rest. Starting from rest means it accelerates later, of course. So after 3.2 seconds of constant acceleration, so speeding up, drill turns at the rate of 2,628 radian per second. Calculate drill's acceleration. So starting from rest means initial angular speed is 0. So initial angular is 0 after 3.2 seconds of constant angular acceleration. This is set time interval after 3.2 seconds, delta t. Of constant acceleration, so you are going to use kinematic equations or definition of angular acceleration. The drill turns at the rate of 2,628 radian per second. Of course, this is the unit of angular speed, but this is final, omega final. So initially at rest, then speeds up, and then gains this angular speed after 3.2 seconds. Calculate drill's angular acceleration. What is alpha in this question? So we are going to use equation for or definition of average angular acceleration, which is omega final minus omega initial divided by delta t. And omega final is 2,628 radian per second minus omega initial is because start from result 0. Don't forget to put in here bracket, because if there is no 0, your calculator can incorrectly calculate the alpha, divided by delta t, which is equal to 3.2 seconds. So now let's do it now. 2,628 divided by 3.2, which is equal to 871 radian per second squared is the answer, which is choice. Let's do the 5, because 5 and normally this 5 and 1 they are asked in the 2012 when there is problems are given, not all multiple choices. They are the same question, but I separated them into 2. Let's continue with it. The same question. Again, start from 0. Initial angular speed is 0. After 3.2 seconds, delta t is equal to 3.2. So the drill turns at a rate final angular speed. But this time, calculate the number of rotations of the drill during the period of time it's asking. How many rotations are there? Angular displacement, normally how many rotations means calculate angular displacement. We will use the angular displacement second kinematic equation because initial is known, final is known, delta t is known, so which means we can use delta theta is equal to 1 over 2 omega initial plus omega final multiplied by delta t. Yes, initial is given 0, final is given this. Here, delta is given, just calculate delta t. So 1 over 2, initial is, as I said, start from rest 0, plus final 2,628, close the bracket, multiplied by delta t, which is 3.2 seconds. Okay, so let's do. Here is the 2,628. 0 is 0, no need to add. Multiply by 3.2. 1 over 2 multiply by 1 over 2 means divide by 2. Divide by 2, which is equal to 4,200 and almost 5 radian. But answer is in revolution, in rotation, it's asked. We should convert angular displacement in radian to angular displacement in revolution or rotation. Delta theta in revolution is equal to delta theta in radian divided by 6.28. You will divide this number by 6.28. 4205 radian divided by 6.28. So divide by 6.20. Divide by 6.28, which is equal to 670 almost. Yes, 670 rotations or revolutions. We can answer it like this. Okay, let's continue with the question on the left side from second. The time rate of change of angular speed. Again, rate of change. So delta t divided by delta t of what? Change of angular speed, delta omega, is equal to, what is delta v over delta omega called? Alpha, average angular acceleration. Angular acceleration is the answer here. And question number 3. A car's tire rotates at an initial angular speed of 21 radian per second. Initial, it's written initial angular speed. This is omega initial. Omega initial. The driver accelerates, so it's an accelerated motion. In what time interval? In what time interval? Delta t is asked. Delta t. Will the angular speed of the tire be 28 radian per second? This is final. Final is given. Because initially, if it is 21, final, it's 28. If the tire's angular acceleration during this time is 1.75 radian per second squared, this is alpha. So we will find delta t. Just use again definition of angular acceleration. Alpha is equal to omega final minus omega initial divided by delta t. Because question is delta t, alpha is given. Just cross product, get a delta t equation, which is omega final minus omega initial divided by alpha. So then let's get delta t. Omega final is 28. Omega initial is 21, but put into bracket. Never forget bracket. Divided by alpha, 1.75. Okay, let's do it. Bracket 28 minus 21. Close the bracket. Divided by 1.75. 4. That is 4 seconds. 4 seconds. And let's do the question number 6 here. Let's continue with fourth one first. A car is traveling at 30 meters per second, undergoes a constant negative acceleration of magnitude 2 meters per second squared when the brakes are applied. How many revolutions does each tire make before the car comes to stop, assuming that the car does not skid and then tires have a radii of 30 centimeters. Okay, in here, this question is asked in 2012. Again, it's when the time there is no multiple choice. This is asked as a classical question. And that's why we are going to, it's going to be a little long in solution. And one more thing, in here, the quantities are given linear. But wanted angular quantity, rotational quantity. So which means you are going to start solving this problem with linear kinematic equation. At the end, you are going to convert what you get to angular or rotational quantity. So initially, it's moving with 30 meters per second. This is initial speed, initial linear speed or initial translational speed undergoes a constant negative acceleration, but this is important word. Magnitude is due, but because it is negative, you are going to write acceleration as negative 2. So acceleration, linear acceleration in here will be negative 2 meters per second squared because it's written negative. Even magnitude is 2, it is negative, so that's why negative 2 must be written here. When the brakes are applied, so it's slowing down. Even you can get that. brakes are applied, which is slowing down. So in slowing down cases, in here we can that acceleration is negative. How many revolutions? What is asking? Delta theta is asked here. How many revolutions does each tire make before car comes to stop? Coming to stop means final speed must be 0. So initial is 30 meters per second because finally it comes to stop. So V final must be equal to 0. Assuming that the car does not skid and then have a radii of each car has a radius 30. So this is R. We will use when it's needed. But to get delta theta, so I will start from the end. To get delta theta, I need to know what delta S is because delta theta can be get from linear quantity or translational quantity by this equation. Delta theta is equal to delta S over R. R is given, yes. Delta S must be first calculated. So linear, by using kinematic equation in linear. So I will calculate what delta S is here. Here is no time is given. I'm going to use the equation without time. So that equation was like this. V final squared is equal to V initial squared plus 2A delta X. It was when it's in one direction motion, but now it's spinning. Delta S we are writing instead of delta X. So final is here is 0. Initial is 30, but squared, 0 squared, let's say, no matter, plus 2, acceleration is negative 2 delta S. So then let's go 0, 900, negative 4 delta S. So then go on, 4 delta S is equal to 900. So which means divide by 4 and divide by 4. Get what delta S is. So I will continue here. Delta S is going to be just from here. We will go. So delta S is 900. This 4 and 4 will simplify. 900 divided by 4, which is equal to 225 meters. 225 meters is the arc length or distance traveled by this tire. And now we can get delta theta. Delta theta is equal to delta S 225. So I will insert it here. R is 30 centimeter, but it must be converted to meter, 0.3. So I will divide 225 by 0.3, which is equal to 750 radian. Still, we didn't get the answer because answer is how many revolutions. We should get angle in revolution. By how? Angle in radian divided by 6.28. I will divide it. Divided by 6.28. I will get angular displacement in revolution, which is 119 revolutions, which is choice C. And the wheel, question number 6, the wheel on an upside down bicycle moves through 11 radian in 2 seconds. This 11 radian angular displacement delta theta. In 2 seconds, its time interval delta t. What is the wheel's angular acceleration? Alpha is the question. Alpha. If initial angular speed is given omega initial, this is one of the practice problem, but 3 times asked in Mr. Exam, same question. So remember, if initial angular speed is given, alpha is given, delta t is given, delta t is given, but alpha is asked, we have just one equation, delta, third equation, which is angular displacement is equal to omega initial delta t plus 1 over 2 alpha delta t squared. Angular displacement is 11 radian, yes. Initial angular speed is 2 radian per second multiplied by time interval is 2 plus 1 over 2 alpha is the question. Delta t is 2 again, square root of 2. Let's go with this. 11 is equal to 2 times 2, 4 plus square root of 2 is 4. 4 divided by 2 is 2 alpha. And then get this 4 other side as negative. 2 alpha is equal to 11 minus 4. So alpha is equal to, this is 7 over 2, which is 3.5 radian per second squared. Answer is B. And last question, 7th. A mass is attached to a string of 50 centimeter long, moving on a circular path. A mass is moving on a circular path. Let's draw a circular path. So, like this, it's moving. This radius of the path is given 50 centimeter, but it's not going to be needed. Starting from rest, which means initial angular speed is 0, completing 43 turns in 1 minute. This 43 turns corresponds to the angular displacement delta theta. In 1 minute, delta t. After 1 minute, what is final angular speed? Initially 0, so then find its angular speed. If it says final is the question. It's an accelerated motion again. What is given here? Delta t is given, delta theta is given, but delta theta is given in revolution. And the initial angular speed is given, and then final is asked. Second equation is the best for this one, because we know that delta theta is equal to 1 over 2 omega initial plus omega final multiplied by delta t. Now look at here, delta theta is given in revolution, but we will convert it radian. Initial is given 0. Final is asked, yes, one unknown. Delta t is given. So then one unknown, we can solve this problem with this equation. Initially get what delta theta in radian is 43 turns, which means 43 revolutions. 43 multiplied by 6.28, you are going to get the result in radian. So let's get 43 times 6.28. It's going to be 270 radian. 270 radian. Now continue with kinematic equation. Delta theta is 270 radian is equal to 1 over 2. Because it starts from rest, initial angular speed is 0. Final is the question. Calculate the final angular speed. Multiplied by delta t. Delta t in minute, 1 minute, but it must be converted to second. 1 minute is 60 seconds. The one unknown, so I can get it. In here, better to do like this. 60 and 2, 1 over 2 multiplied by 60. Well, the multiplication. So then here is 0. The 0 has no effect on the addition. So 60 divided by 2, in fact, this means 270 is equal to 60 divided by 2, which is 30. 0, no need to write. 30 omega final. Divide by 30 now. Divide by 30. Simplify. So 27 divided by 3. Omega final must be 9 radian per second. It is choice A.